Hello and welcome back to the Oxford Online Maths Club. My name's James and this week I'm joined by Eve. This is Eve, who was you were on the live stream last year, right?
Last year, yeah.
And we've got Eve back again to talk about pursuit on graphs. More about that coming up. But first, how are you doing in chat? Hello to anonymous person and anonymous person and anonymous person and Jammy. You can join Slido chat at and where do you go for Slido chat? You go to slido.com/OOMC or at slido.com, put in the event code OOMC for Oxford Online Maths Club, and you can join in this live chat experience like May has just done to say hello, James and Eve. Hello to you as well. You can be anonymous in Slido chat, and it is moderated by, this week, our lovely moderator is Rowan, who is a current student here. If you ask a question that we don't spot on stream, there's a chance that Rowan might reply to your comment in there. I can't remember if I briefed Rowan on that or if they're finding that out now. Okay. We're going to run a poll because I like running a poll. The poll is, as always, how is your day going? Hi, by the way, to Aaron and Ria, and I can see Lucas in there as well. Good to see people back again and good to meet new people. I did a school talk today. I don't know, I'll ask about your day, but I did a school talk today and I remembered to mention that we do Oxford Online Maths Club as well. I don't always remember. How's your day going, Eve?
Pretty good, yeah. It's hardly started. I got here and decided I should write a talk.
Right, of course, you're on a different time zone. So.
Yeah, I know, it's noon here. And it's just been daylight savings, so I was nearly out by an hour for this talk because it's been daylight savings stateside, but not in the UK, because they're not at the same time. Right. Which was brand new information for me.
Right. Daylight saving time, different times in different places. Always an adventure. You're in the States at the moment. Last time you were on the stream, you were not in the States, so you've changed time zones, which is something for me to remember. Hi to Mary in chat as well. Good. Oh, I need to advertise some things. I remembered. For example, the concept of further reading. Each week we do a maths live stream on Thursday, and then at some point on the Friday, or very occasionally Saturday, I write a kind of blog post of things that we forgot to say or didn't have time to say, or things that I said wrong. Never my guest. My guest has never said anything wrong, always me. So that happens on the Maths Club page on the top right there, which might be how you found this YouTube link in the first place. If you want an open day that does more of your sort of questions about maths at Oxford, if you're interested in studying with us for an undergraduate degree, we have open days. You can find out a very similar URL down there with open-days in there to find out more about studying at Oxford. We're doing an in-person open day in April and also a virtual open day. The virtual open day is going to be pretty similar to this sort of experience. There'll be webcams and maths on screen. And we also do some summer open days in Oxford as well. But the big poster at the moment is for another summer school. The summer school is called She Talks Science STEP Summer School. It's at Murray Upwards in Cambridge. It's for women and non-binary students in year 12 who are hoping to do maths. It says at Cambridge on the poster, but I think it works if you're hoping to do maths at university.
If you're planning to sit STEP, I think if you're going to need STEP for any of your applications, so you get 5, I think. And if one of them needs you to take STEP.
Yeah. So STEP's used not just by Cambridge, by some other universities. As it happens, it's not used by Oxford, but I like a summer school as much as the next person, and the next person is Eve. Eve loves a summer school. Right. Okay. So if you want a summer school, I've put their link. Their link is very, very long. I couldn't work out a short URL, so I've put a tiny URL as well. Possibly we'll put a link in the further reading notes as well, so people can click a link.
A note on that, make sure you're using the Murray Edwards link, because if you go to my website at the minute and find it, you'll find a lot of information for the 2024 summer school, because I have not organised my website since then.
Right.
So
Oh yeah, so is this where we reveal like if you search for the name of the summer school, you might find the 2024 version, which was run by you, and your website may be still in the search results. Um, Lucas wants to know about summer schools. Is there any summer school programs that haven't already closed that have links with maths, physics, or engineering? For this summer, it's getting a bit tight to deadlines. I think Promise might have closed applications quite recently, and Unique closed applications in January. This one's currently open if you're female or non-binary. But for this summer, I think we're getting out of the time of year when people apply for the other ones. I don't know. Eva, you aware of other summer schools?
I don't know if Sutton Trust is still running.
Sutton Trust is still a
UKMT
thing,
summer,
as far as I know.
yeah, I don't know when they close. The UKMT summer schools you don't apply for. But I don't know if people know if they're going on those yet.
Yeah, I guess they'll find out, won't they, at some point? The one that's based on.
Yeah, no, I'm just trying to list things that are.
Yeah, I'm currently googling whether Sutton Trust is open or not. This is not obvious, not immediately obvious. It's still a thing. They're still happening.
Yeah.
Southern Trust Summer Schools was some of the first events I ever worked on as a maths student.
Well, that's when I first met you.
Oh, is that how we met? On that sort of summer school? We've done a lot of summer schools.
That's
Right.
true. I feel like it was at least something Sutton Trust based. It might not have been a summer school.
They're still going. We should go. We should go and see what they're up to. Yeah, Tim says that Promise applications have now closed. So if you applied to Promise, hooray! If you looked at the problems anyway, hooray! They had some hard problems. It was kind of fun. I look forward to seeing what they do next year. Ria wants to know about requirements for this summer school, other than being female or non-binary and in year 12 and hoping to study maths at Cambridge or Warwick or doing STEP or something.
You must be taking A-level maths and further maths, not necessarily this year, but you must be planning to have A-levels in both of those things.
Yeah. I think there's eligibility criteria to do with, is it for UK students or something?
Oh yeah, it's home students only. It's not international students.
Check the website, and if you are an international student, there's lots more things going on around the world. Too many to list. Right. Okay. Lucas says Southern Trust is running. They've applied.
There are some eligibility criteria that are for a kind of travel bursary, but those are not to be confused with the application criteria.
Okay. So. Right. Good. Lucas, who asked about summer schools, has applied to both the Cambridge Sutton Trust one and the Oxford Unique one, which I think there we go then. Okay, right. Good. Okay. Pursuit on graphs, I think. Yeah. Over to you. So we're going to look at this. Go and look at this one, right?
Yes. So for our pursuit on graphs, we've got a slightly non-traditional framing of it. You always have someone doing some pursuing, which we're going to have Mario doing the pursuing, and you have somebody doing the evading, so they're trying not to get caught. That's going to be Luigi. So the way it works is they're going to be moving around on a graph. Graph is just, think of it as a network. It's some points, which we've got labeled here by letters. And some of them are joined to each other, some of them are not joined to each other. And the only possible relationship between two places you can be is either they're connected or they're not connected by an edge. So the very first thing that happens is Mario decides where on the graph, which point Mario wants to start at. So let's just put Mario anywhere on the graph. And then Luigi is allowed to, in response to where Mario decides to be, to choose a starting point for Luigi. Now, before we put Luigi down, let's just go through what's going to happen after. So Mario is going to be allowed to move to some neighboring vertex. So at the minute, from H, Mario can move to G, to C, or to I. I've helpfully said those in the opposite order. So it would be a really bad idea for Luigi to choose one of those vertices to go to, because if Luigi does that, then Mario can catch Luigi straight away. So Luigi doesn't want that to happen. So Luigi's going to pick some vertex that is not any of those to start off with, if Luigi's got any sense. So let's just put Luigi anywhere on the graph that it wouldn't be silly to put Luigi.
I've gone for the
Sounds
not obviously stupid A. Can't wait to find
Yeah.
out if that was non-obviously stupid.
You're going to be vindicated. You've actually done the best thing you could have done.
Oh.
So then we proceed by saying, okay, well, Mario's allowed to move. And Mario can move to, we said before, GC or I were the choices for Mario.
Do you want to make the choices for Mario? Or
Does chat want to make them, or should
can we let chat do it?
Yeah, should we poll?
Yeah, look, right, okay. Poll. Oh.
Sorry, I should have.
Right, multiple choice. This is going to be. We've got precedent for this. If people saw, there was an episode where we had a network. It had 18 points. We had to do a kind of solitaire jumping pegs around, and there were so many options at any point, and it was like Twitch plays Pokemon kind of chaos of people trying to jump around. So this is now Twitch plays Pursuit or something, or YouTube plays Pursuit. They are controlling Mario to decide how to try and catch Luigi. They're going to take it in turns to move, right? Are we Luigi, maybe?
Well, let's be Luigi.
We're Luigi. Okay, cool. Right, good. Currently, vote is going quite well. They currently voting for G. I might call it there, I think. C is catching up. I is not that popular. I don't know. Do I understand?
That's good. Yeah, I feel like I shouldn't be that popular.
Yeah. It's not 0. Okay. I'm gonna G and C are now tying, so next vote calls it. The next vote was G. So Mario is moving to G. And sorry to Aaron in chat says I bags Luigi, but I think we've decided we're Luigi. So it's Luigi's turn. What are we gonna do?
So I don't know. I feel like I want to move away from Mario. I feel like Mario's just got closer to us, right?
I think we've got 3 choices and 2 of them are bad.
Yeah, so I feel like F takes us closer to Mario and B takes us closer to Mario. And if I'm at F, like Mario can just move there, right? And
yeah, same for B actually.
Same for B. So unless we're feeling very silly, we're moving to E.
Right. Now I've got to work out how to edit a poll. This is fine. I can go. So the options are now going to be H if you want to go back again, or B, or F. And I also need to reset the options. Where's reset gone? Oh my goodness. Everyone talk to the person next to you. That doesn't really work online, does it?
Everybody do a happy dance.
Is that a thing that we can get them to do online? H.
I get my students to do a happy dance in lecture if they're not talking to me enough.
I didn't really introduce you. Do you want to do an introduction? I don't really say who you are or what you do. Or...
Oh, I teach math at Penn State and variously run outreach things for people in the UK, in Cambridge at the UKMT. I did a PhD in math before I did this.
These are the sort of things that chat's interested in. Teaches maths, does maths. I've managed to get a poll working for Mario. I've done it wrong. I've got one of the options is impossible. Somebody's
James, you have one job.
One job.
No, yeah, you have to have 20 to be fair.
Yeah. Okay, so one person managed to vote for an option that isn't possible, and now all 3 are tying, which is kind of cool. H and B and F. Ooh. It's not the speediest sort of Twitch plays Pokemon kind of thing, but they're getting there. Unless I've become concerned as the person. Yeah, Tim voted for C. Sorry, Tim. I've become concerned as the person running the polls that I might have to create another one because I don't think they're catching us now. So we're going to run, and then I'm going to have to create another poll. So I'm becoming concerned about that. They want to go to H. I don't think I understand why they want to go to H, but here we are.
Yes, because in some sense, if we started at H and A, right? That was how we how we started. And if we kind of tilt our heads, H and E are not that different from H and A, right? Because we've just kind of reflected the graph. So now we're
back where we started.
Yeah, we're back where we started, except slightly relabeled. So why couldn't we go to C is a good question. So we were at G, and in order to be able to go to a vertex, you have to be connected to that vertex by an edge. So there has to be an edge, single edge between G and C. Now you can walk to C via B or via H, and there is a version of this game where you equip people pursuing with helicopters, where they are allowed to kind of go wherever they can see as long as there's nobody in the way. Yeah, in this version, you can only move to places where you're connected by a single edge, and G and C are not connected by a single edge.
Yeah, that person was just rinsing me for putting C as one of the options, I think, briefly. But you've said there's a version of this where you move 2 squares, which would be speed
there's
Mario.
A version where you can move as many as you like, as long as there's nobody in your way.
Nobody in your way? Wait, that's making me think about
okay.
Anyway, okay, we're getting ahead of ourselves. We've got to move Mario, or I guess we've got to think about obviously if they moved Mario to B. So
let's pretend
closer.
they did that. Then we'd be able to kind of confer, and we might not be feeling very clever. We might say, well, let's move Luigi to A.
Yeah. At which point, chat wins because they can capture us at A.
Yeah. And I think Jammy Dodger is saying this can go on forever, which is true. And it going on forever means Mario might not be able to catch Luigi, right? It might be possible for Luigi to escape. So we'd really like to be able to figure out whether or not we can make that mathematical and actually say, I think this game should go on forever. I think no matter what Mario does, it should be possible for Luigi to get away. And that's kind of, this kind of running away around the cycle is one thing, but the problem is, what happens if Mario somehow makes his life better by leaving the cycle? Right? What if he goes somewhere else? How do we know if that Luigi then moves that we've not actually managed to sneak round? So how do we know that this kind of structure doesn't help Mario in some way? So what we're going to think about is actually a concept of distance on the graph. So if we go back to where we started, I think that was with Luigi at A and Mario at H. There's 3 edges separating Mario and Luigi at this point. Now, you could worry that maybe there's a way of getting there in 2 and we've just not been clever enough to find it yet.
There are algorithms for this, I think, that they learn possibly at A level or equivalent for finding the minimum distance. Yeah, but come on, it's obviously, I'm being silly, it's obviously 3, isn't it? That distance between those 2 points.
So in one move, like, what are the possible distances that Mario could end up from Luigi if he starts off 3 edges away and he's allowed to traverse 1 edge in a single move?
Do you mean for this situation, or do you mean in general? They can answer.
Right. How far away could he end up from Luigi? Just thinking about the number of edges between them.
Oh, you see. Maybe they can let us know in chat. Mario is currently distance 3 away. What might happen if Mario makes...
If Mario moves by an edge.
Yeah.
What could happen?
Possibly in a good way, possibly in a bad way. Just like anything. Can you say?
Yeah. I'd like to know all the possibilities.
All the possibilities of how far away is Mario afterwards. Right, let's give chat a second to think about that. Mario is currently a distance 3 away in this example, but also imagining in general, if Mario moves along 1 edge, how far could Mario be as a result of that move? Depends on the point in this example anyway. So there's G and C and I that we thought about. I'm losing my voice, I should stop trying to help chat. Ria's got some numbers in chat, but I'm going to give, as always, I'm going to give people time in case somebody is typing while somebody else sees the chat message. Keep typing. If possible, lots of opinions, even if they agree, even if they disagree. Chat has a kind of running joke where they put more and more question marks on things that they are uncertain about, so as to indicate tone. It's something we struggle with in this sort of text-based thing, that whether they're sincere or not. So, for example, Tim says, "Why couldn't we go to C? No question marks." This is a very sincere sentiment. This is how we communicate. So the votes in chat at the moment.
Marks I see on it sarcastic. I'm going to think it is.
Sorry, say that again.
The more question marks I see on it, the more sarcastic I would think it was.
Right. Yeah.
I wouldn't think of it as extra questioning. I would think of it as extra sarcastic.
Right. Well, maybe that says something about other people you've been interacting with. I guess I don't think chat's sarcastic at all. Chat's getting pretty wrong. Chat at the moment is saying 2 or 3. They've checked. They've checked the possibilities, right?
Yeah, and I agree with chat. And if Mario's trying to catch Luigi, he's trying to be in the same place, right? And that's distance 0. So we would think that kind of being 3 away is in some sense worse than being 2 away. So we'd like to close that gap. So we can kind of get to a situation where Mario will be at distance 2 from Luigi, maybe. Either distance 2 or distance 3. And at that point, Luigi has the option to move an edge. And maybe Luigi will have no choice other than to move closer to Mario. That could be a problem, in which case the distance will become 1 if it's at 2. But if not, he can either stay distance 2 away, maybe distance 3 away, and then we'll be okay. So we'd like to kind of analyze this graph and say, is it possible for Luigi to always kind of maintain some kind of distance from Mario? And yeah, we start off at distance 3, and Mario might stay at distance 3 or might go to distance 2. It's important we're considering all the possibilities, but we could be at 3, we could be at 2. I'm going to introduce, I possibly forgot to say this when I first did it, there's also an option for Luigi or Mario to choose to stay still.
Ooh. Oh, you can just pass the turn instead of moving. I should have been putting that in the poll, shouldn't I?
Yeah, probably. Oops. It's not going to make much of a difference in this game. We'll care about it later.
Okay, so on this graph, it feels like when Mario moves, it's all connected. So there's some route. If it's length 3, then there's some route towards Luigi of length 3. So Mario could walk along that one to get the distance down to 2. Yeah. Or they could do something different, which might keep it the same, or even increase it if they run away from Luigi. I guess that's a possibility. Maybe.
Yeah, so we might worry about that if the distance was 2, but if the distance is 3, you're going to struggle to find a way of increasing it to 4. Because you can see maybe we would feel like H and F were a distance 4 away from each other rather than H and A, but if Mario goes around the outside, they're actually distance 2 from each other.
Oh, right. This is why you told me that putting Luigi at A was the best possible idea, because it's sort of the furthest away. It's not. Yeah. It's not 1 or 2. It's 3, and that's the maximum.
Yeah. So that's the furthest.
Right.
So yeah, they can only be distance 1, 2, or 3 away. So then we kind of get interested in this question of, well, if Mario does move closer, if Mario decreases the distance to 2, can Luigi respond? Can Luigi kind of say, well, you've moved closer, but I can get further away. So yeah, this is this kind of situation. I think when we simulated it, we moved Mario to G. So let's maybe reproduce what we did.
We can't have gone to G. We must have gone to.
No, the first.
Oh right, sorry. We moved Mario to G. Sorry, yeah. Chat moved. Yeah. Sorry, I remember now. Yeah.
Mario to G.
Which brings the distance down to 2. Yeah. Okay.
Yeah, and you and I kind of thought, well, I'd really like to move to E because moving to B and F were an awful idea because they were both distance 1 away from G, right? But really, I'd like to move Luigi to E, and then we did manage to maintain a distance of 3.
Right, so maybe Luigi uses green. Now I've got to put Mario in red. 2 seconds.
Yeah, we can't have Mario in blue. That would be awful.
That'd be really weird. So again, Mario got the distance down from 3 down to 2, but then Luigi has managed to get the distance back up to 3 again. If you're red-green colorblind, then oh gosh, this has been quite tricky. But there's red going down for Mario and then green going back up again. Direction doesn't matter if we're just talking about distances.
No, yeah, direction doesn't matter at all. So, and you know, we could have gone 3 and 3 as well. The point was, after 2 turns, it could still be distance 3. Is there a question in?
Yeah, there's a question about cycles, which I think you're going to get to. So
I'm going to get to that later.
Going to get to cycles.
Worry about that too much. Okay, so we managed it in that case. And now I want to think about the question: Can we always manage that? Was there anything special about the vertices A and H as starting points that allowed us to increase the distance back from 2 up to 3? So are there different situations where we've got vertices that are 3 apart where this strategy isn't going to work? So maybe could we just circle H and A just to emphasize them? So here's an example of some vertices in this graph that are distance 3 apart. And because Luigi kind of chooses the start point, we're always going to pick something that's 3 away from somewhere. Is there any other way that we can set this up where we wouldn't be able to do that in our starting points, or is there anything special about this graph that makes it possible to always do that?
See, because if Luigi escapes, then we've got back to a distance of 3, and even better, I suppose, we're in basically the same position we were when we started.
Yes, because... so then we can run the strategy again. The only problem is we've moved, so is it still applicable that we can do the same thing?
Right. So is it always the case that if you start at distance 3 and Mario makes a move, that Luigi can always get the distance back up to 3? They can always do a kind of escape move to get away from where Mario is about to be.
Yeah.
I don't know. I'll give chat a second. Seems reasonable. Which pairs of things are... I'm trying to think about which pairs of things are distance 3 apart.
Yeah, I think maybe it's more helpful if you pick a vertex to say which other vertices are distance 3.
Okay, so okay. And it's not just distance on the screen, because of course some of the lines are longer than others. It's not as the crow flies, you have to go along the lines. So if I fix H, then these 3 are distance 1. I suppose these 4 are distance 2 around here. And then is it just these 2 that are distance 3?
It's 3 indeed.
Like kind of opposite side of the inside pentagon.
Yeah.
Yes, so people in chat have had time to type a sentence about symmetry. Ria and Anonymous have told us that it's symmetrical. Each starting point that is 3 away is the same case, just rotated or reflected.
Yeah, so and that's most of what's going on, right? If Mario is on the outside pentagon, then Luigi just kind of can be 3 away on the inside pentagon, and if Mario moves to another place on the outside pentagon, Luigi just slides along 1 and will remain distance 3 away, and we're happy. If Mario moves to the inside of the pentagon instead, so if Mario, instead of moving to G, had chosen to move to C in the first move, Luigi started up life at A, remember? Then the escape move now is different, because B is not a good choice because we get caught straight away. E, we won't get caught at straight away, but the distance will have gone down to 2. But if we go to F, then we've got the distance up to 3. It's this kind of mirroring.
So this is a different case, but we can still... There's only a few things Mario might do, and in all of those we can escape off to somewhere else.
But you're saying it's a different case, but secretly it's actually exactly the same case, because if you imagine taking the inner pentagon and just pulling it to the outside, then actually it's exactly the same, right? Because those edges can just go from pointing we've got the one that's going from H to C. We could imagine C being the outside and H being the inside. So you can just turn the whole thing inside out.
Yeah, okay. And just in time, Anonymous says if you imagined it's in 3D space with two pentagons connected to another, in or out, it doesn't really change anything.
Exactly.
It's a pentagonal prism, I guess, viewed in 3D perspective or something.
Yeah.
Like it. Nice. So Luigi can always have a... Yeah, okay.
Yeah. So we actually, by doing that one case where Mario goes to G and saying it's still possible to escape, just using the symmetry of everything on the outer and everything on the inner, everything looks the same locally. And actually the inner and the outer are the same as each other, just by transformation. We can say from every starting point where Mario starts 3 away from Luigi, after Mario's move and then Luigi's, we can always still have distance 3.
Okay.
So Luigi should always be able to get away. So that's that example. I think we understand how the game works now. So let's do some more examples. Could you put me a 4 cycle up?
Someone in chat mentioned cycles. They're thinking about things where the graph goes round and round. Oh, sorry, that's me hitting something with my elbow. They used a clip of our episode last year. They used a clip of it on social media for Oxford Maths. It's the clip of me being bad at drawing. I had to draw a snail last year and said something like, "Oh, professional art." That was in your one.
Yeah, because I got you to draw a snail. I remember that.
Yeah.
And I've got a snail that I could have given you. I just made you look stupid for...
Oh, don't worry. Don't worry. Looking stupid is pretty much my job. Right, here we are. So we've got the Mario Brothers. They're going to play the same game on just a little... You've called this a 4 cycle.
So let's call it a square.
No, you're going to call it a 4 cycle. I'm going to call it a square.
Right.
I guess Mario starts at one of the corners.
Yeah, so loads of symmetry going around,
okay,
right?
Loads of symmetry.
That's what's happening. So it would be a really bad idea to put Luigi at B or D.
Yes.
Because then Luigi gets caught straight away. So we'd better put Luigi at A. We've got no choice.
Yes.
And then again, loads of symmetry going on, right? Mario can go to B, Mario can go to D. We don't really care. And then either Luigi steps on Mario, which is not a good idea, or... So at every single turn, Luigi seems to have this kind of unique move available where he doesn't get caught immediately, and he just can keep doing that. So it seems like Luigi should win here too, just by choosing to be in the opposite corner to Mario all the time.
It's not the case that they have to go round and round and round, because it depends what Mario's doing. Luigi shouldn't commit to going round and round and round, because Mario might outthink him and end up at the same space.
So yeah, Luigi is highly reactive to Mario. So that's kind of maintaining a distance 2, I guess. Mario can cut it down to 1, but Luigi can always pick it back up to 2 if it's as low as 1. And if it's already at 2, Luigi can just stay still. It's really important that Luigi's allowed to stay still here, because if Mario chooses to stay still, then and if Luigi moves towards Mario, he's going to have real problems.
Right. So the third case, if Mario goes to B, you got to stay opposite. If Mario goes to D, you've got to stay opposite, and Mario's allowed to stay still.
Yeah.
And
if Mario stays still, Luigi better stay still.
Also got to stay still to avoid.
Yeah.
Okay. This one's easier to solve, isn't it? We've checked all of the possible things that might happen.
So we might ask, well, what if it wasn't a square? What if it was kind of a 5 cycle, 6 cycle? What if there were more nodes? So I guess you'd call that a pentagon or a hexagon. It's a long time since I did this kind of math.
Yeah, pentagon is 5.
Pentagon is 5. Pentagon I was okay on. Hexagon I really had to start to think.
Professional mathematician. But maybe that's a lesson about professional mathematicians. What's a hexagon? Okay, they're now on a 5 cycle.
Fabulous. And then at this point, there's no kind of... There's not the wonderful symmetry where there was only one place Luigi could go, which made it easier for us last time. But there is kind of... You can see there's a path where Mario's kind of closer to Luigi along one side than the other. Do you see what I mean there?
Yeah. So
he's like 2 away going one direction and 3 away going the other.
2. So Luigi should probably move away from Mario. There's like a well-defined
Luigi
sort of
can
array.
only move away from Mario whilst moving toward, right? He's increasing one distance to 3, but the other one to 2.
Huh.
Yeah. So
Yeah.
yeah. So we haven't really achieved anything there. What we've done is we've not moved any closer.
Yes. We didn't run towards Mario. We've survived this turn. Felicity says the max distance is 2, possibly talking about the square.
Yeah.
Yes,
yeah.
But also it's true that the max distance is 2 on this pentagon.
Yeah. But that's okay, right? Rather than necessarily mirroring Mario here, what we're going to do is if Mario decreases the distance, if the distance goes to 1, we just, whichever direction Mario has decreased the distance, we just run away in the direction. Yeah.
Okay.
And options to stay still if Mario doesn't decrease the distance to 1. But if he does, then we can run away. And it feels like this should generalize, right? It feels like if he runs towards me in some direction, I run away and increase the distance. Should work on any cycle, right? And indeed it does. So if we have 6 sides, 7 sides, 8 sides, we can keep doing this. It stops working though if we make the cycle smaller. So if we try this on a triangle, we put Mario down on the graph somewhere, anywhere. Again, it's symmetric, doesn't really matter where.
Sorry, I'm slightly slower at this than I thought I would be. There we go. So Mario goes on the graph somewhere.
And then I can only put Luigi in places that are already directly in Mario's path. So as soon as Mario moves, Luigi's caught on a triangle. Luigi has no hope on the triangle. So this kind of triangle case is somewhat vexing because all of the cycles Luigi should win, except that the triangle, it doesn't happen.
We've got an example now where Mario wins, so that's good.
Yeah, it is possible for Mario to win. So let's look at a completely different case now. Could you just draw me a path, like a path with 3 edges, maybe 4? It doesn't really matter. Maybe, yeah,
this?
maybe that's fine. That'll do. So yeah, we can imagine putting Mario somewhere on this line, maybe at one end, and Luigi could pick to go close to Mario, which feels like a bad idea, or far away from Mario. I mean, maybe there's clever reasons it would be good to start close to Mario. In this case, no. So Luigi's only options are kind of to stay still or move closer, and Mario can choose to move closer to Luigi. So I think he's going to do that, and kind of, in some sense, he's cut off Luigi's only escape route, right? There's no way of... So Luigi can just kind of pin Mario can pin Luigi in this line and just walk until there's absolutely nowhere for Luigi to go.
Right, so we've got and this is another case. It's not an exciting game, but it's one where Mario wins. Because Mario can just charge down the hallway, and if the hallway has an end, then Luigi is sort of trapped in that corner.
Exactly, but you can modify it, and we might think, okay, well, what happens if we give Luigi an extra escape route? So could you just add to me a kind of a junction at the end, one vertex on either side?
Ooh,
maybe.
Okay, like a little fishtail.
Fishtail, yeah, we can maybe make it longer. It doesn't really matter. Yeah. So could we maybe at this point poll whether we think this is a Mario win or a Luigi win?
So is this Mario win where, yes, is this a part of Mario's victory arc where Mario can always catch Luigi? Or is this a Luigi win where for Luigi to win, Luigi would need to kind of escape forever?
Luigi a way of being tied forever.
I guess Luigi doesn't really get a moment of winning so much as Luigi demonstrates a mathematical proof that Luigi can always...
Yeah, Luigi has a strategy for not getting caught for forever.
It feels like possibly... I'm going to think out loud. I don't know the answer. So you've added an extra branch. So it feels like maybe Luigi could use that by running down one of the branches, and then no wait. I had a second half of my plan, but I'm going to keep it to myself for a second. It's about turning around and surprising Mario the other way. Felicity feels sorry for Luigi. It's a suggestion that the game involves some sort of jumping, and maybe we should allow. Is that, I think, if you can move distance to. Something you said earlier makes sense to me. You said moving multiple spaces. You could consider that, provided there's no one in the way. And now that I've seen the corridor, I understand that.
What in the way means. So yeah, there are versions of this game where maybe Luigi has guards who can stop Mario from. Okay. There's so many versions of this. I'd like us to focus on this example for now. Okay. But yeah, you can vary this in so many ways.
Felicity thinks it's a Mario win. Anonymous thinks it's a Mario win.
Yeah, and in fact, it is a Mario win. A Mario win for the same reason as the last one. So maybe to start with, it feels like Luigi has some options. So if you can kind of think there'll be a direction joining Mario to Luigi. So Mario will be kind of there's a center to this graph, right? That point you've got Luigi at the minute feels in some way a center.
Right. Okay. Like the middle is here.
Yeah. And Mario can just kind of, wherever Mario starts, Mario can kind of push Luigi towards that center until Mario is at that center.
And then once Mario's at the center, whichever bit Luigi in is like a hallway of death.
So then we put it into ways where Luigi's just backed up against the end of each of those corridors and can't go anymore. So Mario will always win on here as well. What we don't have on these is any cycles, right? There's no kind of places where Luigi can just kind of do the game we did earlier, where he's just like, oh, Mario's over there, I'm going to move a bit further away. And as Mario, depending on which direction Mario goes, Luigi can change which direction he goes in a way that increases the distance, which is what doesn't happen here. So this kind of begs the question, if there's a cycle in the graph, and it's not a triangle, because a triangle in some sense is too small, does that always mean Luigi can win?
I typed it. So we've seen lots of examples with cycles where Luigi won, except for this triangle. And we've seen lots of examples of like hallways and tree-shaped things. It's a tree if you look at it sideways, chat. This is the trunk and these are the branches. Graph theory is fun. If there's a cycle and the graph is not a triangle, does Luigi always win? I've just noticed Felicity said something interesting in chat about knowing where Luigi is. There's possibly a version of this with Fog of War.
But there is a version of this where Luigi is invisible. Again.
Every time you mention a version of this, I think, I've got to put it in the further reading. I've got to put a write-up of all of the other alternative versions.
Very, very long for
this. Yeah, okay. Let's give them a moment. So it's a hard question because now you're asking about kind of asking about all graphs. I don't really know how much.
Yeah, is there one we can think of where there's a cycle in it where maybe Mario would do well? Maybe was there anything in any of the cycles we did earlier that we'd be able to change that would mean Luigi's strategy was not so good anymore?
Yeah,
so I guess the strategy in the square was to remain opposite Mario, right? To be at that, there was only ever one place Luigi could choose to be that would help.
It was that kind of mischievous behaviour of just being opposite. Whatever you do, I'll do the opposite. I've seen that before in other games where the right thing is to just do the opposite of whatever the other player's done. This is me setting up further reading notes. Don't mind me. Don't mind me. not gonna do it now. Because in the triangle, there was a loop where Mario wins. Because
yeah.
actually, even if you let Luigi go first, right?
So yeah, that's the solution. If you build bridges on this square, which is in chat now, then you can make it a Mario wing graph. So if we just add a bridge from A to C, then we break Luigi's strategy, right? Because if Mario starts off at A and Luigi starts off at C, bad idea to start off at B or C, then all of a sudden A is too good a vertex, right? It's connected to absolutely everything. It doesn't matter where Luigi goes. Mario can catch Luigi from A. If Mario says, I'm going to be at A, there's nothing Luigi can do.
See, so this is an example where there is a cycle, but the cycle has extra connections, and that helps Mario to win.
Yeah, so kind of the problem with the trees was that they weren't connected enough in some sense. Luigi kind of, once he was somewhere, he had only one way of getting places, and he couldn't get away without evading Mario. Whereas in some sense, this is too connected, because Mario can get absolutely everywhere from just one place. So that gives us some problems. And in some sense, the same problem is occurring with the triangle. If you look at the triangle, the problem with it is that it doesn't matter where you put Mario, he can get everywhere.
Chat's done something brilliant, which is very mathematician, which I would just like to highlight, which is two, maybe three, here they come. Two people at least have thought, well, that's not what I meant, right? They said Luigi should win if there's a cycle. They've clarified that they mean not triangles, which I think is very mathematician to say, well, I've got a new hypothesis, right? You go out and check a thing and see if it's true or not. And then it doesn't really matter if you were correct or not in your intuition, we go and do stuff. But then maybe you have a new idea, which I think might be if there's a, and the graph, maybe the refinement is something like, and the graph has no triangles or something, has no cycles of length 3 as a kind of refinement. So this refinement in bold due to chat. And that was a harder question. I have no idea.
Yeah. In some sense, these triangles are different to each other, right? Because the reason that just the one triangle makes it fail is because Mario can get everywhere on that triangle. And yeah, do you see what I mean?
Yeah, so it's not quite true that Mario is using one of the triangles rather than the other, but it's about the connections between.
It's about the fact that there are these places that you can get everywhere from that are kind of making things worse.
I'd have maybe guessed that having lots of triangles would be good for Luigi, because Luigi could go to just a different faraway triangle. So possibly, I don't know if this is true or false at the bottom now with the refinement.
Yeah, the actual criterion is a bit more ugly than that. But
there's a true fact here. Okay, good.
hinges on this kind of idea. So kind of what I want us to think about is this idea of kind of places it's good for Mario to be or places it's bad for Luigi to be. So C is a dreadful place for Luigi to choose to be, right? Because if Mario is at A, then it doesn't matter if Luigi stays still or if he goes to any of the neighboring vertices. C is kind of a trap for Luigi. Because if Mario's at A, then there's problems.
Okay.
And we can make this formal. There's actually a definition for this. So if you take a vertex and you look at all of its neighbors, all the places you could go from there, if that's the same as we have here, if that's kind of contained in the places you can get from a different vertex, then we kind of say it's a danger zone. So how would I write this criterion down? So if you look at C, C together with its neighborhood is B, C, and D.
And A, maybe? Because it's connected?
Oh, and A, sorry, and A also, yeah. And all of those are reachable from A.
Right, there's a point where Mario could sit that monitors all of Luigi's possibilities. In this case, it's A. And just the fact that Mario might be there is enough for it to be a danger zone.
So we say A dominates the vertex C because every option from C is also an option from A. And if Mario was sat at A, that'd give Luigi some real problems.
Good. Okay. There's a different generalization of the fact in chat, and I should say these are hypotheses, chat, that you can investigate by trying lots of different graphs and seeing does your pattern generalize. So someone said, is it about whether you can trace the graph without lifting your pen off the page, which is a kind of criteria about graphs. Might be related. It's a hypothesis you can think about.
Definitely gives you a set of examples of Luigi wing graphs if you can't, if it's not connected. If it's in two disconnected pieces, you can definitely put Mario down in one of them and then Luigi picks the other one. And then there's no path from Mario to Luigi. So Luigi's going to be very safe on those graphs.
I've got a feeling they're also worried about graphs with lots of odd vertices. I think that's what they're worried about with drawing it in one stroke without taking your pen off the page. Possibly that's related, possibly not. I don't know.
Yeah, I don't
graph.
Yeah, you'd investigate that definitely.
10 minutes on the clock. If that's
yeah. So
okay.
Could we write that definition down?
Yes. Sorry. Could you tell me it again?
So the idea is you're looking at where you are and where you could possibly go in the next move. So for example, if we're at vertex C and we're thinking, what if Mario was at A? Well, we say A dominates C if everywhere you can get from C, including by staying still, is also somewhere you can get from A.
Ooh. I just had a quick look back at our starting graph, and I think none of the vertices in our starting graph dominate any of the other vertices in the starting graph.
No, yeah, and that was one of the things that helped it be a Luigi win, was that actually, you know, there's no vertex that's particularly strong or particularly weak. It's very, very symmetric. So kind of a very extreme example of this are very, very connected graphs where you can get anywhere from any vertex. And in that case, every vertex dominates every other vertex because you can get everywhere from everywhere.
I'm going to draw it because I think it is a counterexample for some of the things people have claimed in chat.
Yeah.
It's not quite a counterexample for the thing on the board at the moment because this is going to have a lot of triangles. But here's a graph that has a cycle of length 4. So it has a nice big cycle, but Luigi can't use that for escaping because every vertex dominates every other vertex.
So wherever Luigi tries to go, Mario will be able to get there from wherever Mario happens to be. So this is kind of an extra bad graph for Luigi. And it turns out the actual kind of criterion for checking whether or not Mario should win or Luigi should win sort of can only be done one step at a time. So you can't kind of look at a graph and go, oh, it's got this one property and that makes it Mario win or Luigi win, and it's straightforward. What you can do is you can say, well, if this graph is Luigi win, then I can build this kind of related one that Luigi will win on, and it's simpler. Or I can build this related one that Mario will win in, and it's a bit simpler.
That's interesting. That tells me that I think that the world of graphs is very complicated, and that you can't just
yeah. Even though it feels kind of like as simple as you can get. Here's some places. Here's some connections between them. Actually, they can get really quite complex. So really, what's going on is let's kind of look at our 4 cycle with a line in it again, and let's just imagine that there's some other connections going from B and D and A maybe.
It's a bigger graph.
It's a bigger graph, but I don't care what's going on the rest of the graph. So maybe B and D and A have other connections.
Sorry.
Yeah. So we can kind of think about Luigi's strategy, and Luigi is always kind of thinking one step ahead, right? Luigi is always aiming to not be caught next time, because the aim is always to survive one more turn. And we can kind of notice that going to C is just not a good idea for Luigi, right? Every time Luigi goes to C, he's either got there from B or from D. Right? He was either at B or he was at D before, or from A, I guess. He was at one of those three before.
Yes.
And so he made the decision to put himself in this kind of somewhat vulnerable position at C, where it might be bad if Mario was at A. And it would have been a better decision for Luigi to go to A, because there's more escape routes, maybe.
A doesn't have this problem, you're saying, because it could maybe be connected to more
Well,
stuff.
A might have this problem, but it's definitely not worse than C.
Oh, yes, fine, okay. Possibly Luigi is just doomed. We're on one of these complicated graphs where Luigi's doomed, but
Yeah.
but at least you'd have some. At least you'd have some fun. At least you have some options. Okay.
So if he's choosing to go to C, then we could have said, well, you know, maybe he'd have been better off going to A. And the only problem we can say is, what if Mario could then have caught him at A? Right? What if the game changed because he chose to be at A instead of at C? What if it was possible for him to be caught at A?
Yeah, Mario.
But if it was possible for Mario to catch him at A, then that means it was possible for Mario to get to A whilst Luigi was at C.
Oh, you're working backwards from the death condition sort of thing. If this is a lose condition for Luigi, I think I get it. If this is a lose condition for Luigi, then working back a step, anywhere where Mario could be about to get to A,
yeah,
and Luigi could be about to get to C, Mario's off here somewhere. Luigi really shouldn't go to C because that would be bad.
Well, yeah, Luigi shouldn't go to C. Every time he does go to C, he could go to A.
Yes.
Now, the only problem is, what if that choice to go to A doomed him? What if that choice to go to A was the reason Mario catches him? But if it was, then when he chose to go to C, Mario could have chosen to go to A, and from there he was doomed anyway.
Doomed anyway. Right. I think I'm getting it. So sort of, you're considering the both possibilities, and it's hard for me to balance them because they're all bad for Luigi. So it turns out to not really matter or something. But
yeah, we're kind of saying if Luigi is doomed by going to A, he's also doomed by going to C, I think. But it might be that he can go to A and it was better than going to C.
Right. This is a sort of
might be escape from A that there weren't from C.
Right, so you're mathematically proving that A is better than C intuitively because there's an escape route, but sort of actually because logically,
it's definitely not worse than C. It's definitely not worse than C, is what I'm saying.
If this doesn't work out, then it wouldn't have worked out to go to C anyway.
No, because Mario could have kind of, in that move where we said Mario catches Luigi at A, then Mario would have caught Luigi at C in 2 moves anyway.
Would have delayed the inevitable, perhaps, but yes, okay.
We could have maybe delayed it by 2 moves, but that doesn't affect the outcome.
No, yeah, okay.
So what we can say is actually we can change the game so that every time Luigi would have made the decision to go to C, instead he chooses to go to A, and it will never affect the outcome.
Does that let us remove the node C from consideration?
Yes, it's the node C from consideration. Make the graph smaller.
So if we're considering going to C is so bad that we're never going to consider any strategies where you go to C, so now Just forget about, say, smaller graph, fewer edges.
So if there's
like
any vertex which is dominated by another vertex, you can say, well, if you delete it, should Luigi win or should Mario win? And you've made the graph smaller.
You can make it smaller
If there's
it's
no
really
vertex,
simple.
if there's no vertex that's dominated by any other vertex, then that means there's an escape route from every vertex and Luigi should win.
Oh, right, because our danger zone definition is almost the opposite of what we were saying about escapes. Earlier. There's there's dominating thing is the opposite of that green arrow that we drew about an hour ago.
Yeah, that means...
It's a big zoom out. There you go.
Yeah.
Good.
That's kind of fast on the punchline, but I'm conscious of time.
No, I think you got the theme of there is some sort of reason why you could consider a smaller graph and remove a case because it's really bad for Luigi. Which I think is a kind of recursive idea, and it's not induction. It's a recursive thing that's not just inducting. I think. Maybe not. No comment. Okay, shouldn't comment. Right. At that point, I think I would say it's 6 o'clock. So we're going to say if anyone's got questions for Eve quickly about graphs or pursuit. Either way, we sometimes put notes on other stuff in the further reading notes. Do check the Maths Club website, maths.ox.ac.uk/r/club for further reading notes. Whenever I write those, probably tomorrow. We're supported by the Maths Institute and by Jane Street. Jane Street have just delivered a big box of t-shirts that I'm quite excited by. So possibly I'm going to wear a Jane Street t-shirt. Aaron would like to know about real world use for pursuit.
I think this was originally applied for like tracking missiles.
Oh gosh.
I think that was one of the contexts when it was. Full disclaimer, I realised someone might ask me this question. I Googled it an hour before this talk. So I don't know a lot about applications, but tracking systems in general.
I can see how that would be a kind of interception sort of thing. I think there's a version of this which is about... I think I've done some continuous versions of this where instead of being on a graph or a grid, you're on just real space and you can move around continuously. And those ones are related to sort of just trying to catch things in the real world. Interception. Ria wants to know if you spend days just drawing Marios and Luigis at university. Can if you like.
My research was not on pursuit and evasion. My research was on partitions, and I spent a lot of time drawing Tetris.
Right. the Tetris pieces. Cool. Yeah. University involves lots of things. You get to study lots of things. I have no idea if Ria's asking that in the mode of somebody who would love to draw Mario and Luigi chasing each other around a graph for years, in which case, great, glad you liked it. Or if they would like nothing less, in which case, great news.
The answer is, like, it doesn't matter what the problem is, there is always a context that you can find that will make it appropriately silly or appropriately serious as suits your tastes.
If you are not a fan of the Mario Brothers, then I guess you can replace this with like a popular choice is a person and a lion. I think for the sort of lion is trying to get you, and you need to escape from the lion. That sounds like a real life application, so I'm going to roll with that. You need to escape from a lion. You're both on K5, the graph that's complete. Bad news, lion's going to get you. Oh yeah, somebody in chat says, was Tim's idea about shortest length of any cycle greater than 3, was that the right answer?
I'm not entirely sure. I don't...
We can leave it as a question.
Yeah, I would like to leave it as a question. I haven't thought about it. The easy ways of constructing vertices that dominate each other consist of writing down triangles, but I can't. I feel like there should be a clever way of saying no. Here's a counterexample.
So is there? I think it's kind of this one on the screen, right? If there's a cycle, but not any triangles, I think that's what I put on the screen as well. And Tim's hypothesis is that, yeah, that's it. Luigi always wins those cases. I think that's not, even if Luigi wins all of them, we're not saying that's all of the cases that Luigi wins. We've got other ones out there that Luigi wins. Yeah, so maybe we can have that as a kind of a question. And someone in chat has already replied with an example where they claimed that Luigi would win, even if there is a triangle for the counter positive, to disprove the converse.
Doesn't mean you have to spend your life on it. Yeah.
Yes, you can put a triangle somewhere irrelevant, and Luigi is allowed to ignore it and just get on with escaping via the sensible bits of the graph. So yeah, chat's done really well today. Well done, chat, for joining in with proof, hypothesis, counterexample, investigation, finding out what's out there. There is, I think Eve's already suggested there is quite a lot going on. Something to think about. Good. The hypotheses are still coming, but we need to stop, I think. Eve, thank you very much for coming on the live stream and showing us.
Thank you for the
graphs. Is there anything that you want to advertise or plug quickly at the end of Maths Club?
I said Step Summer School already.
Put it back on the screen for you.
I've got on my website a partition combinatorics kind of reading activity if anyone wants to look at that. It's not been updated in a while, but it's kind of self-guided problems. So if you like this kind of combinatorial thinking, it's aimed at about year 12. So
again, the perfect plug, which is the summer school and also a maths activity. That's brilliant. Right, thank you very much, Eve. Thank you very much, chat. We'll be back next week for another episode of the Oxford Online Maths Club. We will see you in 167 hours. Until then, have a good evening, have a good weekend. Take care, everyone. Bye. Yes, and then after that great sign off, I need to press the button that actually makes it stop being live. Yes, bye.